Hey guys, welcome back to the channel. My name is Zahir, and before I begin the topic that we'll be learning today, I want to quickly run the actual implementation of what we will be learning. So here we go. What you're seeing on the screen essentially is we are running some query classification or intent recognition of a query, and the query is going through multiple intent classifiers, so to speak, and we are getting the output. So once this is done, I'm going to walk you through what we're talking about here. Okay. Yeah. I think it's done. Let me quickly walk you through this. So we have what we are seeing right now on the screen is basically a simple demonstration of how query routing or query intent recognition can happen, and the relevant routing can happen in an agentic system. So the query is, where is my order? And we have written 4 different types of routing systems, or four different types of intent classifiers, and this is what the output is. For the LLM, routing, the LLM classifier or the LLM intent recognizer identified that to be ordered status. The embedded system or the semantic routing system also identified that as an order status. The rule-based routing system identified that as an order status, and the machine learning based routing system also identified that an order status. But let's also look at some other queries. The query here is, what are the technical specifications of your latest smartphone? And this is the output we are seeing. Just about all the routing systems have got it right, but there is just the machine learning model which has got it as technical support. Okay, let's look at the last one. In fact, there are 2. My app keeps crashing when I try to log in. This is the query, and the output or the intent. The output of the intent classifiers are, LLM, embedding, and ML have got it as technical support, and which is right. But the rule-based engine has got it as general. Same with I was charged twice for my last order. Need a refund. LLM and embedding have got it as billing, and rule and ML have got it as order status. Rule, that is rule routing, rule-based routing, and ML-based routing. And you know that LLM and embedding are right here. Okay. All right. Now, how did we arrive at this? Let me actually talk about what we'll be learning today and why I have written this multiple classifiers or intent classifiers, and which one should you be writing, and which one would actually help you in essentially building your complex multi-agent systems. Okay, with that, let's get started. I'm going to quickly show you guys what I have first. I have a simple illustration of what we'll be building, or what I've actually built. So the user essentially keys in a query, and we are trying to build a customer service agent. And this agent essentially takes, the router agent essentially takes the query and routes it to the relevant agent or a sub agent, right? Obviously, we'll be not writing agents here, but what we'll try and understand is what kind of routing system that we need to add here. Should it be a LLM-based routing system? Should that be a machine learning-based routing system, or should that be a semantic or embedding-based routing system, or should that be a rule-based routing system? When should you pick each one of this, and what is the ideal one in general for you to actually work with? Okay, and one of the reasons why you should also consider this is because I got this very good illustration from the internet. Most of your multi-agent systems would probably look something like this. And this is a very simple agent. As you can see, it has a few nodes only. But in a real-world multi-agent system, there is a lot of decision-making that the LLM will help you do, right? You could have an agent. You could, in your multi-agent system, you have a triage agent or a supervisor agent that will essentially route your request to your different agent systems that the sub agents that you have. Your own sub agents could probably have sub agents, that is multi-level agentic system. So how do you essentially build a clean routing system so that the LLMs or the agent can essentially uh, be reliable for you, and most importantly, it is also efficient, and from a performance point of view is also very performant. Okay, so let's look at the code now. Like I said, I'll go back to this illustration. We'll be looking at these different types of routing system: LLM-based routing, semantic or embedding-based routing system, the rules-based routing system, and ML-based routing system. That is machine learning-based, simple classifier system. Okay, so let me also show you the repo. I'd very strongly recommend that you continue to follow this particular repo in my GitHub account. The report is called Agent Expert Labs, and I'll be adding a lot of agents going forward here. So any core concept that we will learn will be added into the core concepts directory. And today, as we're learning routing, I have added everything here. This was a lot of work. I'm hoping that you like this and you also share this with your friends. All right, we'll get started with the code. Let's actually look at the patterns that we'll be learning and run each and every pattern. You would need a few packages here. You don't need this because I realized that this is going to make the system slow. And I have used OpenAI's text embedding model, so we're good there. But essentially, to make this work, you will need to import a few libraries. Now, mainly so scikit-learn, pandas, or you might not need pandas. We don't even need matplotlib. Let me actually remove what we don't need here. Yeah, so essentially you need LangGraph, OpenAI, and scikit-learn. These are the primary packages that you need to make this work. Obviously LangGraph, so that we use the LangGraph system to build an agent, OpenAI to essentially work with an LLM, and scikit-learn to create a custom machine learning classification model to identify an intent. All right, so we made some simple imports here. Now let's look at the LLM routing first. So I'm going to delete this. We don't need this here at this point in time. All right. We need to obviously essentially define the result of every classifier, and our classifier essentially needs to have 3 fields. The first field is the route that we're taking, and like we said, we have 4 different let's call it sub-agents or nodes or methods that we want the query to be routed to. So we have order status, product info, technical support, billing, and there is a generic node or class or agent called general. Okay, if the condition doesn't meet, the query doesn't meet any of this, so it'll be routed to a general. We also need the confidence score of any classifier that we are working with, so that we have a minimum threshold in our agentic system, and beyond, if the threshold is not met, or the minimum threshold is not met, that is, let's say, if the confidence score is less than maybe 0.75 or 0.8, then you don't want to essentially use this and route it to general, or have a simple error method written that, can you add more context? I did not understand your query, something like that. Okay. And method is basically just to tell which routing method this is. All right. So with that established, let me actually first walk you guys through the LLM routing method. Now, the LLM routing method is very simple. We want an LLM to essentially make the decision for us, that is identifying the intent based on the query. What we will do here, like any other agentic system that we have in our YouTube channel, or any other agentic system that you've learned, essentially we will pass the entire context of all the nodes, classes, or agents that we are supporting as part of the prompt. That is, we are going to teach the LLM that this is the in context. Basically, this is the description of all the tools that we have. Understand the description and understand the query, and pick the right category or tool that we have here. Okay, so as you can see, I've written a very simple query. Questions about order tracking, delivery shipping status is for order status, product info is this, technical support would be technical issues, troubleshooting bugs and problems. So the LLM is smart enough to understand this. But in a production system, you can imagine you could probably have an MCP system which has a lot of tools, and all of those tools essentially will be passed as context to the LLM, so that the LLM can essentially decide the right tool for you, so that it can pick the right tool and call. But if it is multi-agent systems, let's say, if you're using OpenAI's agent SDK, you essentially tell the triage or the supervisor agent that these are these other different sub agents that you have access to. Pick the relevant agent. Something similar here. You're essentially passing the description of all the nodes that you'll be working, or all the categories that you'll be working as context. Okay. Uh, we have a simple client here, that is the OpenAI client. We create an OpenAI client so that we can essentially call GPT-4o Mini, and we pass that as that is a prompt as the user prompt, and we have set the temperature to 0 because I don't want it to be creative. I want the result or output to be as grounded as possible to the information that is being provided with. Okay. One thing also that we are trying to do here is we want the response to be in a specific format. So I'm returning the routing result, the routing result object, or the class that we just created here. Let me show you that again. This one, and I want 3 fields from it. That is route, confidence, and method. Okay, we have established that. I have actually run a lot of this already, so I'm going to clear output again, and let's try and run it again. So let me quickly run this. We'll be importing all the libraries first. Let's run this particular cell as well, and we'll run the LLM routing session. Now let's ask it, what are the technical specifications of your latest smartphone? That would be the query. Let's see what the response is. All right, so it is saying the response as product info, which is good because I think it's got the intent right here. What are the technical specifications of your latest smartphone? And the output was also in 2 seconds, which is not ideal, but considering that it's an LLM, it's fine. Okay, I'm going to also ask it one more query. Where is my order 1, 2, 3, 4, 5? Let's see what the intent is. Order status, great. I'm going to ask it maybe, how do I track my order? Order status again. Yeah. So the query was, I have an issue with the checkout page. Select them. So some seems to be working. All right. So we know that the LLM-based routing, how that works, you essentially pass the entire context of all the tools or nodes or regions that you have to an LLM. The LLM essentially decides that. Very simple implementation. Let's look at the next concept, which is semantic routing. Here, what we intend to do essentially is we want to capture as much details as possible about all the nodes, the categories, the tools or agents that we have, where we want the query to be routed to. And the idea is that we turn that into embeddings and store them in a database, a vector database like ChromaDB and others. In this case, I'm not going to be do that. I'm just going to be running that, in the cell directly, and we will take the output of the embeddings and then simply check the similarity score and return the routing from that. It's a very simple implementation, the same similar implementation that you would use in a RAG-based system. Here we are converting the order, that is the different agent node or classes that you have, and the descriptions of them into embeddings. We'll also turn the query into an embedding as well, using the same embedding model that we'll be using. And in this case, we'll be using text embedding 3 small from OpenAI. And we will return the most similar, category here based on the query. Again, the similarity will be against the description that we have added here. Let's see how that works. So I'm going to run this now. And my query is, what are the technical specifications of your latest smartphone? This is going to take a few seconds because it has to first turn that into embeddings. and then return the response. So we'll see how this goes. All right, so it has returned this product info, and the confidence score is not very good. The query is, what are technical specifications of your latest smartphone? Let's see if it returns for another query. I have an issue with the checkout page, something similar that we have given there. Let's see what it does. Again, it's rightly pointed to technical score, but I'm not very happy with the confidence score. And the reason also is because you look at the description that we've captured here. The description probably needs to be a little more detailed so that the confidence increases. We'll have to provide it with a lot more examples. A lot more examples should be added to the description. And then you can use the semantic router with very high confidence score. But yet it is actually identifying the right, the right route or the right node or a category, right? One final check. What is the status of my order? The reason you see that second time is because we're generating embeddings on the fly and then doing a comparison, essentially getting a similarity score of order status. So this seems to be working fine as well. The next one is rule-based routing, and the rule-based routing essentially entails using regex and then extracting relevant keywords. First of all, maintaining a dictionary of the possible keywords that we want to extract or we expect in a query, and then essentially working with it. So if you see, getting the regex part right is going to be crucial. Building this dictionary of all the possible keywords that the user could ask is crucial. So this is not a very reliable method, as you can see. This need not be, the regex need not be the only way that you can do this. You probably have very strong entity recognition system, and you can build an intent classifier out of that. There are multiple NLP techniques here, but I'm just trying to show you that if you build a rule-based system, then this is one of the ways that you can write this. So let's see what is the output that we get. So I am going to run the rule-based routing now, and goes without saying, this is probably the fastest setting that you will see, and in fact, this is the fastest routing method that you'll see, because obviously this is simple if-else condition. We're getting the output in almost nanoseconds now. Let me change the query. How do I track my order? Yeah, this is pretty sure. Yeah, order status goes without saying. Let me give it. I have an issue with the checkout page. We haven't. Oh, it was able to find this because I think it found the word issue in the technical support dictionary. Let me go there. Issue. There it is. That's why it was able to rightly select the node as technical support. All right, so we know how that works now. Now, the last routing method that we'll be looking at is the machine learning based routing method. Now, what we have done here essentially is, and I want to show you that particular class. I've written a simple classifier class where I have basically created a custom machine learning model by training it with possible examples of the utters or queries and labeling each and every utter with the possible category or the category that utter should essentially route us to. So here some examples for order status examples. Where is my order? It's an order status. Where will my order arrive? Order status, so on and so forth. Similarly, I've created examples for product info. I've created examples for technical support. And I've also created examples for billing and general examples. All right. So I have used scikit-learn to essentially, create a simple model here. We are using logistic regression to essentially create a classification model, and I've created a pickle file out of it. So let me run. Let me go back to, yeah. So let me run that. So what we're doing essentially here is we are loading the ML classifier, and it is here. in the same directory. It's called customer service classifier.pickle. And once we load it, we simply run use the predict API to essentially um, pass the query and get the relevant results. So I'm going to run this cell now, and we'll generate the order. So what is the order status of 124? This is going to be very fast as well, not as fast as the rules-based engine, but this is going to be relatively faster than using either the semantic model or a large language model to essentially get the classification done. Uh, this also depends on the complexity and the number of tools that you have access to. The problem here is, or the drawback here is that you'll have to continuously keep updating your model with possible letters, and every time you add a new node or tool or an agent, you should continuously update your model, which is a bit of a stretch if you ask me. And the overhead of maintaining that and getting that and continuously testing and evaluating model is higher. But this is definitely one of the options that we have, and you should definitely consider that if you have the resources to do that, and if you don't want to depend on an LLM to make those decisions for you. So we ran that query, but I'm going to run a different query now. What is the status of my order? No, I think we've run our order query, but let me actually run this. Yeah, it's the order status again. I have an issue with the checkout page. It's technical support. Great. Let me look at something else. How are you today? It should be general. All right. We have looked at all the patterns now, and you've seen how we can actually build this routing systems by either creating machine learning based models, more machine learning classifiers essentially. You can use an LLM by passing it all the context of tools and agents and sub agents that it has access to, and you can either use simple if-else rules-based systems to essentially identify the intent, and also you can use RAG-based or embedding-based routing system to identify intent. Now, what we will do is we will actually run the entire system. I want to quickly walk you through the code of what we are trying to do here. So essentially, this is how our LangGraph node looks. I mean, I don't want to spend a lot of time in the code. It's very simple. You can go through the code on your own. We have a router, and the idea is that the router, based on the type of query that is coming in, it identifies the intent and routes it to the relevant node here. There are different nodes: billing, general, order status, product info, and technical support. And each of the nodes essentially return a response and end, or basically print a response. We will not go through the details of how you should be setting up this graph, but I'll quickly show you the simple structure of how we have written this. I've essentially created a customer service router, and the reason I'm doing this is because I want the I want to be able to essentially just by passing some arguments here, that is basically passing the query, I want to be able to pick one of the routing mechanisms, in fact, all the routing mechanisms also in a demo, and then print the different outputs that we are getting from each of the routing systems. Okay. That's the idea. That's why I have written a class. I essentially copied all the methods that I've written here in routing patterns into this particular class. The class name is customer service router. And then we have some nodes here. These are handle order status, handle product info. This could be a very large class that essentially is calling multiple APIs, but we are just trying to simulate what the response is here. Handle product info, handle technical support. These are simple nodes that we are trying to, we've created for representation only. There is the there are nodes that also that we've created. As you can see, the LLM router node. The LLM router node essentially, we pass that information to the LLM, and then we capture that as a state in LangGraph. Similarly, we do that with embedding-based routing here, and we've created a node for all of them, as you can see. Okay, there is a route query here. The route query essentially simply returns the state that is the current route that is selected. That's all it does. What does it do? It essentially calls the route query method, and we get the relevant, uh, the relevant query, no, the relevant, I'm sorry, the relevant node as output here. That's it. So we add all the nodes. We add all the nodes, and we simply, compile the workflow. And I have shown you the illustration or the visualization of how that particular graph looks like. Now run this. Let's run this once again. So I have so many queries. I'm sorry. There is a demo routing methods here. The reason I've written this is because I want to essentially test all the routing methods with the same query and print the results. Okay, so we have essentially initialized the state, the customer service state. We are passing it the query. That's all. That's what you need to do. It's a very simple router, and we will invoke the graph that we just created. We'll pass the state to the graph and invoke it, and we'll print the result. So let's do that one by one. I've run this already in the beginning, as you saw, but let me run it again, and you should see this in action. So the first query is where is my order, and we got different results here. The LLM embedding rule, and that is rule-based routing and ML routing. All of them basically predicted it right, or got the intent right, which is order status. The next query is, what are the technical specifications of your latest smartphone? You see that the machine learning model didn't get it right. What are the technical specifications? Also, probably has to do with how we, train this particular, train the particular machine learning model with all the possible letters. Maybe we didn't train with this. That's why we are seeing this. But this is not about the machine learning. Sorry, this is not a technical support query where we want to know more about the product, as you can see. The next one is, my app keeps crashing. This is a technical support. All the routing systems have got it right, barring rule. The possible reason is that the rule engine doesn't have a keyword called crashing. That's why. That's why you see that the rule-based if-else condition, unless and until you're very sure about the possible letters you're getting, it's a very risky routing mechanism. You don't want to use that. The possible confidence score that you'll get is also very less. This is a bit of a misnomer, but I think in general the scores are all LLM embedding and machine learning models have got it right, although you see varying confidence scores here. The confidence score also is has got to do with the training data. The more training data you have, the better confidence scores that you'll get, at least with the embedding model, because you have the precision. Okay, let's look at the next one. I was charged twice for my last order, need a refund. This is about billing or order. This is a bit of a ambiguous query, right? Because you have the word order present as well, but the actual intent is to basically get a refund, which means it needs to be routed to billing. Both rule and ML, because they are dependent on the rules that are written or the data that it is getting trained on. They have picked it as order because they probably found the word order in the query. But LLM and embedding actually understand the meaning of the query, and that's why they were able to rightly point it to billing, which is awesome. Can you help me with general information? Again, this is because without saying all of them have got it right here. All right, folks, that's all I had in this video. Routing is going to be a very foundational yet a core concept of how multi-agent systems work. You would want to try with multiple routing mechanisms, like we have done LLM-based, embedding-based, or semantic routing, rule-based, or machine learning model-based routing, and see what works for you for your use case. Obviously, this was a very simple example, a very simple illustration, but you get the point on how to essentially work with this. All right, folks. I hope this was useful. Please like and subscribe and share this video with your friends and network. Uh, until next time, thank you.